Hi, I would like to go through an example of the demonstration outline, step 7 of this project. So basically, right before spring break, you're going to have your oral communication graded, your presentation, and so it's going to be called your demonstration. So this is the outline that's going to help you develop that presentation that you need to be able to give right before spring break. So we have our the big pieces. So you're going to introduce your demonstration. You're going to demonstrate your reaction. You're going to discuss your experimental plan. You're going to give your experimental results and data. That's a lot of math. That's my favorite part. And then you will have a conclusion to the presentation. Okay, so I'm going to go through these steps. So remember how in RAPS class you have experimented with filling up the balloon. So I'm going to take one of those examples and talk through it. So why is educating others about your reaction important? RAP and I had decided to use positive view of personal future as our developmental asset. So it is important because sometimes we can be scared about what our future holds. We need to be able to fill ourselves with thoughts and plans that will help our future be big and bright. And then it says, how will you catch the audience attention in this introduction? So the best ways to catch audience attention is to start with asking questions, start with statistics, start with an emotional story to get our hearts connected to your presentation. So how will you catch the attention of the audience in the introduction? So that's how that first part's going to go. You'll start your presentation. You need to catch our attention, and then we want to know the why. Why is this important? Then you're going to demonstrate your reaction. You should start by telling us what are the things, or actually maybe you don't even need to talk about this part. I think this will be the stuff that naturally happens, like who's going to pour the vinegar, who's going to do the measuring, who's going to do that stuff, who's going to make sure it's all ready when it's time, like whose stuff is needed. So if you have any questions about what this would look like, blah, 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 RAP can help you, right? So I'm not saying that this is complete or a work, but it's enough to hopefully walk you through the pieces. Next is when you're going to start discussing your experimental plan. So start with your hypothesis. You guys, a lot of this work has already been done and it's been approved by us. So you just need to put it all together so you can build the best presentation that you can. So look at your step 6, your experimental plan, and your hypothesis should be on there. So the one I'm going to use is if we use 21 milliliters of vinegar for this reaction, then we will have the largest circumference because all the baking soda will be used and there will not be any extra vinegar. Then you can talk about why you chose this experiment. We chose it because we wanted our balloon to be the biggest it possibly could. And so we wanted to experiment to see how that could possibly happen. Your manipulated variable is your X. So that's what are you changing each time? Remember, in experiment, you're only changing one thing at a time. So what are you changing? And then what are you measuring? That's for the one that we're doing, it's the circumference of the balloon. Then you're going to explain your experimental results and data. And you can do that by inserting with Desmos or drawing the table graph or images, like whatever that's going to work for you. In fact, what I did is I took one of the pieces of information from what you guys have been doing in class, and I just used my snippet tool, which I know is different for you guys on the Chromebook, but I just went to my table that we've made and I snipped it, copied, pasted it right here. So then I didn't have to worry about having to retype the stuff. Then I used Desmos to come up with a graph. You can use Desmos if you want. That's not cheating. You can also graph it on paper, take a picture, whatever works for you. But remember, it's desmos.com, and then you'll hit the plus sign and the table, and then you have to type it in. It needs to look like a table in order for all of this to work with Desmos. So record your table, and you may need to adjust your screen. You can pinch, zoom in and out, and it'll make it bigger or smaller, or you can use this little wrench and that's going to give you the settings and you can set the window to show what you need it to. And then again, I just used my snippet tool and put it, copy and pasted it over here. Then you need to stop and get a teacher's initials, preferably mine since I'm the math teacher. But if I'm not available, Miss Rapp or Miss Eldred or Miss G would also be able to sign that off. Then you're going to describe the association that you see in the graph. So this one, I'm going to say that it's mostly linear and positive. Minus these few down here, it kind of looks like it's moving in the right direction. So you're going to, if yours is going down, but pretty close in a straight line, then that's a negative linear. If it goes like this and then back down, that would be nonlinear. So you get to decide what that looks like. Discuss clustering and outliers. I'm going to say 17 and 25. I don't know that they're far enough away to be outliers, but they definitely don't match the data. So they they alert me that I need to think about what could have possibly happened there. And then you're going to reflect on your hypothesis. Was it accurate? Why or why not? So I'm going to stop there and let that sink in and then tune in for video 2 to start here on reflecting.